Okay, so what we're going to start looking at is the graphs of some exponential functions. So on the first page of this note sheet that I had given you guys, there were three functions that I wanted to fill out the table of values and discuss. I've already done that. So now I just want to talk about some features of each of these functions. Now, when we take a look at example number 1, which was f of x equals 2x, this is a linear function. Now, most of you are really familiar with linear functions that come of the form y equals mx plus b. Well, this function is of that form. We just happen to have a y-intercept that is 0. Now, one characteristic of the linear functions that you need to be aware of is that they increase at a constant rate. So every time my x increases by 1, in this case, my y is increasing by 2. And the graphs of them form a line. Now, in this linear function, we can also discuss the end behaviors of it. Now remember, as this says, as x is approaching infinity, that means we're looking at the right side of our graph. So as my x's go towards infinity, my y's are going towards infinity as well. And as my x's are going towards negative infinity, the y's are going towards negative infinity. So this linear function is something that you guys are familiar with and you've seen before. Well, when we start taking a look now at examples 2 and 3, these are called exponential functions. And the reason that they're exponential functions is because the variable is in the denominator. Not denominator. I'm not redoing the video for that word. The variable is in the exponent. So when I completed this table of values, I just plugged it into my calculator. To do your exponents, remember you can hit the caret key, which looks like this and is above division, and then hit math frac to turn them into fractions. Now there is one characteristic of these tables that I do want to point out to you, that when I raise 2 to the first, I get 2, but when we raise 2 to the negative 1, we get 1/2, and these are reciprocals. And so the same thing's happening when I do negative 2. When I raise it to the negative 2, I get 1/4, but when I raise it to the positive 2, I get 4. So when I'm filling out tables for exponential functions, I tend to fill out the positive parts first, and then I know that when I raise it to the negative, that those are reciprocals. So it kind of makes your life a little easier when you're filling these out. Now, when we take a look at this graph, one thing that you need to know is that exponential functions have a feature that the other graphs that we've done so far have not had. And that is, they have what we call an asymptote. And in this case, our asymptote is this x-axis, or the line, y equals 0. Now, when we're talking about an asymptote, we're talking about a line the function approaches, but does not reach or touch. So what's happening here is my x's are going towards negative infinity. These values of y are going to get super small, but they're never going to touch 0 or go into the negatives. So we could end up with like 0.000000 something, and you're never going to quite get to 0. And so that's why this is considered an asymptote. And in this case, it's a horizontal asymptote, which I will refer to from here on out as the ha. Now, in this graph, as x is approaching infinity, my y's are approaching infinity. They're going to keep getting bigger and bigger quickly. Well, as my x is approaching negative infinity, this graph is going to start to level out there, at 0, so we're going to say that it's going to be approaching 0. Now, this graph looks similar to it. It looks like it's been reflected over the line y equals x, which it has technically. But in this case, I also am going to have a horizontal asymptote at y equals 0, which we represent with dashed lines. A lot of you guys will find that using a highlighter will make it easier for you to see your asymptotes. So if you want to do that, just go ahead and highlight that as a dashed line. It might make it more visible to you guys. But as x is getting bigger and bigger and bigger and bigger and bigger, the same thing's going to happen that we saw happen in the other graph. It's going to keep going closer and closer to 0, but never quite reach 0. So when I look at my end behaviors, as x approaches infinity, f of x is going towards 0. Now, as x is going towards negative infinity, now this is increasing. So that's going towards positive infinity. Now, each of these functions is representing an exponential function. But in this function, as my x's are increasing, my y's are increasing. So we consider this function to be exponential growth. And this function is exponential decay. I start off with some really large values, but as my x's are increasing, my y's are decreasing. So these graphs are the basic graphs of exponential functions. What we're going to do next is we're going to look at how to shift these and find some other characteristics of them.